All right, let's take a look at, this is your homework assignment here. So we're going to do it like we did before. I'm going to work through a couple of problems, and then you have to finish up the rest of them. And so whatever we don't do today in class, you'll turn in 1 week from today. Finance worksheet 2. This first one is a problem to get you to think about, and this is from section 3.3, future value annuity. Because there's a regular payment, she invests $3,000. Remember, the big difference between an annuity and just a compound interest problem is that in an annuity, you're making regular payments or regular investments, something regular leaving somebody's pocket. And here it says $3,000 per year. So the implication is that there are going to be multiple payments every year. So it's an annuity. Here's the formula that we don't use a whole lot. You can see since t is up in the exponent there, it would require logarithms to solve it. So the algebra to solve this problem is a mess. So instead we go and use the Tvm Solver. She wants to be a millionaire in her lifetime. So she wants to accumulate in the future $1 million. She invests $3,000 per year. Red probably doesn't show up. So that's her payment. And the payment in this case really means an investment. Generally, when you start investing, you start with 0 in the account. The interest rate is 8. And then it says how long. So what we're looking for is the value of n. Here it says she invests $3,000 per year. Once at the end of the first year, once at the end of the second year, once at the end of the third year. And so these are not monthly payments, they're not quarterly payments, they're one payment per year. And so the payments per year and the compounding per year will each be 1. And you might be interested in that, you're young. How many years do you have to work to achieve $1 million if you just put in $3,000 a year? Well, let's take a look. 8% interest, start with nothing, contribute 3,000, and your goal is $1 million, making 1 payment per year. There's a retirement instrument out there called an IRA, an individual retirement account. There's 2 kinds. There's a Roth IRA and there's a traditional IRA. If you're thinking about investing in an IRA, I would strongly recommend the Roth IRA. Because with the Roth IRA, you are charged taxes on it now. That is, in years when you don't have the highest income that you will make in your lifetime. So it's not going to put you in a higher tax bracket. But when you take the money out at the end, you won't have to pay taxes on it. And I think the limit here is like $6,000 this year, 6 or 7,000, I forget what it is. And so if you want to invest in an IRA, maybe 6 or 7,000 would be more appropriate. All right, so the how long, the n is what we're going to calculate. So as you know, we move the cursor up there, and then we do alpha, the green key, and then enter to get solve. So this is 43. So and this is the number 1. So this represents the number of years, not the number of months or the number of quarters. This is the number of years. And since 43 years is not quite going to do it, you probably should do 44 years of investing in the same amount. Then after 44 years, you will have $1 million. Okay, so when M is 1 and the rate is 0.8 and the future value is 100,000, all of these will be consistent. Find the T. And we just did this one right here when the payment was 3,000. So we're going to put about 43 years here. And it was actually 43.14167623, that number. So what I would like you to do is to fill out the rest of this table. So for example, it's not going to take you as long to achieve $1 million if you're putting away $12,000. So with most of this information still the same, we change the payment to $12,000 and go back up and calculate the N. And you can see here, if you put away $12,000 every year, that's $1,000 per month, then it's only going to take about 26.5 years. And then I want you to kind of look at these numbers as they come down. As your payment increases, what happens to the time it takes to achieve $1 million? So I want you to kind of look at the table at the end. And the only thing I did to get this number down here was I changed the payment amount to 12,000, negative 12,000 instead of the negative 3,000. So with the TVM solver, you can knock this entire column out pretty quickly. You're changing one number and calculating n again, changing another that payment number and calculating n again. All right, let's go over to the other table. Now for this one, we already, with the payment of 3,000, the target value of $1 million, one payment per year. When we selected 8% up here, we had the 43 years. So that very first problem that we calculated here is going to fit both here and here. In this table, however, we're changing the interest rate. So you get a choice of where you invest your money. Are you going to keep it in the bank? If you keep it in the bank, you're going to earn 1%, and you may never become a millionaire in your lifetime. You have to take a little bit of risk when you're investing, and you want to try to get up around 5%. If you can get 8% or 9% or something higher, great. But most investors cannot achieve that rate consistently over time. So generally, when financial advisors are working on things like this, they will assume that we're going to make a conservative 4 or 5%. That way you can invest the money conservatively. And let's see. So this one, this whole problem, the payment is going to be the $3,000. So I'll do one more of these, and let me jump down to 5%. If we do 5%, then the only other, all right, so there's the original setup. If you choose the 5% here, the only number that you have to change is to come up here and change the 8 to a 5. The payment is 3,000. The target value is $1 million. One payment per year. Start with nothing. Calculate. Okay, so you can see if you get a lower interest rate, it's going to take many, many more years for you to achieve $1 million. All right, so I'm going to say about 59 years. Now, however, if you go and you do 20%, look at this one. If you change the interest rate to 20, how long will you have to work? If you're a smart investor and you know where to put your money, it's only going to take 23 years. But most investors cannot make 20% per year on their investments. It's just, it means that you're going to invest in some risky things. And if you invest in risky things, you have a higher probability of losing money. So when your financial advisors can advise you, they'll say, well, what kind of interest rate do you want to achieve? And if you say 5%, they can put you in a very conservative portfolio of investments so that you lose a little bit when the market is down and you gain a little bit when the market is up, but it stays pretty much consistent so that you achieve 5% throughout. Some years a little bit more than 5, some years a little bit less than 5. Now, that's a wiser way of investing for the future than investing all in risky assets where, yeah, in the long run, you're going to earn 5%, but some years it's going to go up and earn 30%, and in other years you're going to lose 30%. So if your goal is to make 5%, why not just kind of stay nice and conservative and without all that risk? And so financial advisors will take you through that. And investing for your future is for everybody, not just for rich people. Over half of Americans own stock. Okay, I'll let you finish up the rest of that. Let's go to the next one. This one is also important for you as you're going out and working for a company, or if you're this would work with a traditional IRA as well, although the traditional IRAs, they don't allow you to put as much money in. In 2020, this year, if you have a 401k, and many of you, if you work for a company, they will set up an IRA for you. And my son, when he worked for this company, they said, you can't participate in our 401k plan for a year. You have to be here for a year before you can participate. But when you do, we are going to contribute 3% of your salary to your 401k, but only if you match it. And so there are many, many Americans, less than 20% actually take advantage of the full benefits of their 401k plan. And it's sad because you're really throwing away money if you don't. The original question that I posed is, if you knew that there was an investment that you could make a 20% guaranteed return on your investment, would you take it? And hopefully you would say yes to that question. Because you saw in that previous example, if you're earning 20%, it's only going to take you 23 years to become a millionaire in your lifetime. So here's the example of how you can get a guaranteed 20% or even more return on your investment if you invest, and it's guaranteed if you invest in a 401k. All right, so here's our person here. And let's say that the person makes an annual income equal to $50,000. Now there are two people here. The first column is the smart investor. I'll call it the smart investor. And it will not be unusual when you go out and you get your 4-year degree that your first year job will be paying you I would say $40,000 to $45,000 in your first year job. And every year after that, your income typically goes up. So some of you, after you get your 4-year degree, or even 2-year degree, will be making $50,000 a year. My son, he graduated a couple years ago. His first year salary was $38,000. And now it's much higher than that. Now it's 65, and I think he's been working for 4 years. But get that credential. Don't drop any of your classes. Struggle through, fight hard, and get that degree and get out and get a job, and you can be working this amount. Now, this investor is going to take $19,500 of that, because this is the total amount that they will allow you to take in 2020. This is the maximum that they will allow you to put into a 401k. So I just use that number. Now, you might say to yourself, well, if I'm making $50,000, there's no way I'm going to afford to put away close to 20,000 of that. You know, I've got to live, I've got to eat, got to have a little fun. So, but if you have a spouse, if you have a significant other, a partner, and you're living together and you're both making this amount of money, then maybe it could be the case that together you could each put away or maybe one of you has a 401k and the other one does not. So maybe one of you could put away this amount of money. All right. The second person over here makes the 50,000, but just says, you know what, I can't afford to put away any money in the 401k. Most people are between these two amounts. But let's see what the implications are if you put some of that money away into a 401k. The federal government, when they charge you taxes, if you put $19,000 in a 401k, they don't charge you taxes on that money going in. They're going to charge you taxes rather when you take it out. So the first person will subtract the $19,500, the amount that they invest in their 401k in a year, from the 50 that they earn. So in terms of the IRS, the federal government, they're only going to charge you taxes on $31,000 instead of on $50,000. All right, I just made up some percentages here, but they're fairly consistent average percentages of somebody who makes this amount of money, how much they would be charged, and it's maybe 10.7%. So let's first figure out how much they're going to pay in federal taxes. And both of them, let's say, are charged the same amount. And this might not be an appropriate, let's just keep it. We have a progressive tax system. I'm just looking at these problems right now. And I'm going to change them. And since it's progressive, the more income that you make, the higher taxes that you pay. And so I'm going to change this. I'm going to leave this number at 10.7%, but I'm going to change this one to 12.3%. Because this person makes more in the eyes of the IRS, they're going to be taxed at a higher rate. And I'll have to change these problems. Okay, so 10.7% of the $31,000 is $3,370.50. Now this person is going to be charged a little bit more net tax for the federal government because they make more money in the eyes of the, and so we raise this up a little bit to 0.123 times the 50,000. So this one is charged over $6,000 just to pay for their federal tax. And we also have state tax. And the state, many states, most states work the same way. They don't charge you on money that you put away for your investment. So let's take 0.04 times the 31.5, and there's another $1,260, $1,260 that goes to the state. Whereas over here, 4%, which is the Michigan state tax rate, times the total income, $2,000. So you're saving on both the federal taxes and you're saving on the state taxes. So let's take a look at the total savings. The first person pays $2,000 in state taxes and $6,150 in federal taxes. The second person pays $3,370.50 in federal taxes and $1,260 in state taxes. So what I'm going to do is I'm going to add those two numbers and add those two numbers and subtract them to find out what is the difference in the tax burden between these two individuals, the one that invests in the 401k and the one that doesn't. So we'll add those two together, 8150, and then subtract these two numbers. And that total savings is 3519.50. Now, in 1 year, one person, these two folks make the same amount of money, but one person pays less taxes. And if you're paying less taxes, that means that money is still in your account or still in your pocket. And so just by investing in the 401k, you've saved this amount of money right here. So what we're going to do is we're going to take that amount of money, 3519, and determine what is the rate of return on that money that I just saved. Well, I had to invest the $19,500 in order to save that amount of money. So I'm going to take this amount and divide by this amount, and that will be my rate of return. And so about 18.0%. So in this case, for this particular person, they made a instant rate of return of 18%. And if you're out there investing right now, you know how difficult it is to earn 18% on an investment. All right, so follow through this with me here because I'm going to make some changes. Somebody who makes more money is going to pay more taxes. So I'm just going to get rid of the 14.7 and put 14.7% here as the first person, but the second person is going to actually pay more. You know, they might be, let's say, 18.3%. And we would actually have to go calculate their taxes in order to know what's most appropriate. So that's in part B. Change those two. And then in part C, it's similar, although we're dealing with a married couple. Well, let's do 16.3% in federal taxes. Consistently, it's 4% because everybody has to pay 4% in the state of Michigan, regardless of how much you make. But for the federal tax rates, it's progressive. And so let's just say that this is going to be 20.7%. Make more money, get taxed at a higher rate, a net tax rate. Okay, so what I'd like you to do is just to replicate what we did here for these two problems, and then calculate the total rate of return on the savings. the point is that if you have an opportunity to invest in a 401k at your employer, you definitely should do it. Now, you might know that teachers don't make a whole lot of money, but one of the things that teachers do have is a nice pension. And anyone that works with the government has a nice pension. And for me, Delta College contributes 10% of my salary every year to a 401k. For education in the health fields, it's not called a 401k, it's called a 403b. So 403b is the same thing as a 401k. I don't know if there's any differences in the tax code, but this is for educators and health professionals. So if you work at a hospital and they give you one of the benefits is a 403b, then they would normally contribute a significant chunk of your salary to your 401k, as long as you match it. So my son right now, they're offering a 5% match. Now the match means that any dollars that you put in, we will match them up to 5% of your salary. So if he's making, let's just take a round number like $60,000, 5% of that, well, 10% is $6,000. So 5% is equal to $3,000. And then, so Alan contributes 5%. Employer will match it, 5%. Now, let's say that Alan can only contribute 1%. Well, if Alan contributes 1%, then that means he's only investing $600 a year. And the employer says, okay, we'll match it. 1%, 600. So if your employer is going to match your 401k, then you need to strive to put the maximum amount away. Because look at the difference in what your employer is paying you. By your action and your action alone, you chose to pay $600, invest 1%, and so your employer only gave you $600. You're losing out on $2,400 a year, which is a significant chunk. So always, as they say, max out your 401k, the one that your employer is matching. Okay, let's do the last problem now. This is one where hopefully you learn the importance of investing early and often. And so we have two investors here, and I'm just going to read this problem, and I'm going to go through these questions, and then I'm going to fill out a table similar to this so that you can see where all the numbers go. So much has been written about the importance of investing early and often. And let's say two friends save for retirement over a 40-year period. If you're saving for retirement, it's going to be usually over a long period. In two different ways. First, we have Johnny on the spot, and he invests $4,000 per year at 8% annual interest for the first 20 years, and then stops and invests nothing else for the last 20 years. So here's Johnny on the spot. Again, I'm going to draw a grid here for the first 20 years. There is a payment being made of $4,000. In the last 20 years, the payment is equal to 0. So in the last 20 years, Johnny just basically says, you know, I've got enough money, I've saved enough money, I don't need to put any more of my money away. I'm just going to let the money that's currently in there just grow according to an interest rate. In the first 20 years, the interest rate is 8%. The number of years is 20. The payment is $4,000. And the payment is going to be, or the investment is going to occur $4,000 per year. Not monthly, not quarterly, but yearly. And so the value of M is equal to 1. In the next 20 years, the interest rate is still sitting in the, let's see, during the last 20 years, his investments accumulated interest at 9%. So in the last 20 years, R is going to be 9 instead of 8. The money's still sitting in the account, so you still earn interest on the money sitting there. a new set of years, and once again, interest is going to be compounded once per year because they don't give us anything else. So this really is a two-step problem. In the first part, because there's a payment made, this is an annuity. And then in the last part of the year, it's not an annuity because there is no regular payment being made. We say that this is just a kind of a lump sum investment. Just to invest one chunk, like the house in the group project, it just gains a certain amount of value, 1.2%. And there's nothing else being added onto the house. All right, two-step problem. We start here with a present value of 0. And then over here, we want to know, with this annuity, what is the future value? So we start with $0 and we start investing. We invest for 20 years at an interest rate of 8, starting off with $0, making a yearly payment of $4,000. We want to know how much we're going to have in the future if we only make one payment per year and the interest is compounded yearly as well. All right, so this is a standard problem for the TVM solver. Enter in all of the inputs, get all the values you know, and then move your cursor to the one you're trying to find. And then at that point, you do alpha, solve on your calculator, and you can see that $4,000 for 25 years, or 20 years, $4,000 for 20 years. The total investment would have been $80,000, but because of compound interest, that $80,000 grew to $183,000. So compound interest at work. Okay, now, after the investing stops per month, we know that at this point, we have a present value of 183,047.86. We're basically going to take this money, which was the future value in our previous example, it becomes the present value in our next example. Our payment is going to be 0, and once again, we want to calculate the new future value. So we start off again, n is equal to 20, only because we're not investing in the last 20 years. These two are the same. The interest rate in the last 20 years goes up 1% to 9%. The present value starts at 183,047.86. Now the payment in those last 20 years is 0. Future value is what we're after. And again, the payments per year, compounding per year is just 1. So this is the second step of the problem. Enter in all the inputs that you know. I probably should put a negative sign in front of this because it's really cash out. We're investing it. And if we're investing it, we have a chance to lose it. So cash out is negative. The only problem here is that if you leave it as a positive, your future value will be negative. It might look strange. All right, so everything is set up. And then we calculate. And look at that. Johnny on the spot is a millionaire. And Johnny on the spot invested $80,000 and turned $80,000 of his own money into $1 million. And the only thing that he had to do that, other than his $80,000, was time. Time and a nice interest rate. Okay, so that's how much Johnny on the spot is going to have. He invested $80,000, $4,000 for 20 years. So you don't have to invest your entire paycheck to become a millionaire. Just a small chunk, $4,000 a year, and that works out to, you know, $350 a month. How much did Johnny on the spot invest over the 40-year period? $80,000. How much did he end up with? $1,025,875.40. All right, so these two deal with Johnny on the spot. We have not done Johnny Come Lately yet. Johnny Come Lately is next. All right, I'm going to maybe speed it up a little bit. The big idea here is that one investor is going to start early and invest over a long period of time, and the other investor is going to wait. And we're going to look at the implication of waiting. So here's Johnny come lately. I'll do a similar grid. Let's read the problem again. Johnny come lately invested nothing for the first 20 years, but then invested 10,000 per year over the last 20 years. So again, it's broken down by 20 years and 20 years. But there's nothing happening in the first 20 years for Johnny come lately. So Johnny come lately starts here with nothing. There's no money. But he is going to invest 20 for 20 years at the 9% interest, starting with nothing, making a payment of much larger than Johnny on the spot. He knows that he's going to have to invest more per year to catch up. In fact, if you take 10,000 a year and multiply it by 20, Johnny come lately is going to invest $20,000, whereas Johnny on the spot only invested $80,000. Let's see if Johnny come lately, because he invested so much more money, 2.5 times more money, if he's going to end up with more money. Again, and throughout this whole problem, there's no mention of a compounding factor. And for Johnny come lately, it's not a two-step problem, because really we're only interested in doing the math for the last 20 years because there's nothing made in the first 20 years. So we start with 0. We make payments of $10,000 per year. So everything is set up. And then Johnny come lately will make this amount of money. Still very nice. That's a $500,000. So if we just consider Johnny come lately as an individual investor, if you can put away $10,000 for 20 years, it's, well, you'd have to have a good, nice interest rate here, but you could end up with a $500,000. So let's finish up. Johnny come lately invested $200,000, $10,000 for each of 20 years, and ended up with $511,000, almost just a little bit over $500,000. So hopefully you'll see that Johnny on the spot was the wiser investor. He invested $120,000 less out of his own pocket than Johnny come lately, but ended up with $500,000 more. And the only explanation for why this happens, and it will happen this way, is that Johnny on the spot started early. Started early when maybe he was 20, 25.